Namaste, Namaste JVWU. I JV'N Gaurav from the Faculty of Physiotherapy and Diagnostics in the Department of Diagnostic and Community Health in the discipline Radiology from JV'N University. Today we are discussing a session that is important or useful session for application of radiation imaging technique or radiographic technique and general radiation physics. So today's session will be helpful for the student to know or understand the general radiation physics or production of X-rays or any type of particles or rays or the positioning of patient. Okay. Namaste. In today's session, we will discuss about the attenuation. Attenuation is a term that is used for absorption plus scattering, okay, of any radiation in type of photons. That is a session from general radiation physics taken in BScRT second semester. Let me discuss about the attenuation. The term attenuation refers both absorption and scattering. Absorption and scattering. Absorption by the tissue and scattering from the any surface, any irregular surfaces. When a photon passes through the absorber of thickness x, when a photon passes through the absorber of thickness x, both absorption and scattering takes place. When a photon passes through the absorber of thickness x, means any object or any tissue of thickness x, both the absorption and scattering takes place. As a result, the transmitted beam will have less number of photons. As a result, the transmitted beam will have less number of photons. This can be represented by the I is equal to I naught E minus mu x. Okay, where I is the number of transmitted photons, I naught is the number of incident photons, E is the base of the natural logarithm, and mu is the linear attenuation coefficient. So attenuation refers to absorption scattering takes place by a thickness of absorber or any material or tissue. As a result, the transmitted beam will have less number of photons. This can be represented by I is equal to I naught E minus mu x. Okay. Mu is the linear attenuation coefficient. What is the linear attenuation coefficient? It is defined as a reduction in the radiation intensity per unit per path length and expressed in centimeter verse 1. Okay. So thank you. In this session, we have discussed about the attenuation of radiation. It is very useful when we are discussing about the interaction of radiation with matter. It is also a very important session. Thank you. Namaste. In today's session, we will discuss about the linear attenuation coefficient. That is also related with the attenuation that we have discussed in the earlier or previous session. Okay. This session is very much important when we are discussing about the thickness that is reduces the radiation intensity or radiation. Linear attenuation coefficient, it is defined as a reduction in the radiation intensity per unit path length and expressed in centimeter inverse per. The linear attenuation coefficient is related to the term half value layer. half value layer or half value thickness. It means the layer thickness of the layer that reduces the intensity to 50% of the previous intensity. Mu linear attenuation coefficient is equal to 0.693 by HVL divided by HVL half value layer thickness. The thickness of the material that attenuates an X-ray beam by 50% is a half value layer. For diagnostic X-ray beam energies, the HVL for soft tissue ranges from 2.5 to 3 centimeter. The linear attenuation coefficient depends on the energy of the photon energy that is used to incident on any soft tissue or any organ, and the nature of the material. The attenuation of photon beam is caused by four important processes, namely coherent scattering, photoelectric effect, third competence scattering, or fourth pair production. These are the four effects. These are the four types of effects in which the attenuation of photon beam occurs or caused. Okay, so in this session we have discussed about the linear attenuation coefficient, or the value of linear attenuation coefficient is calculated by the formula 0.693 divided by half value thickness or half value layer. Thank you. The session is over. I think this session is very much useful for when we are discussing, when we are studying, when we are studying the interaction between the radiation with matter, with any material, okay, or in the presence of any observer. Thank you. Namaste. In today's session, we will discuss about the heat unit. So, in the earlier or previous session, we have discussed about the linear attenuation coefficient. Now, in this session, we have now we are discussing about the heat unit. To know the exposure, we have to calculate the energy deposited in the target. Okay, energy deposited in the target is equal to the kVp multiplied by Ma multiplied by exposure time in second. The product of these three factors are expressed in unit. So energy deposited in target is equal to the heat unit. The maximum energy depends upon the characteristic and waveform of the electrical supply or voltage supply. The energy deposited may be estimated for full wave rectifier is energy is equal to 0.75 multiplied by heat unit. In the case of 3-phase or 6-phase circuit, the energy deposited is equal to 1.35 multiplied by heat unit. Energy deposited is equal to kVp Ma, kVp multiplied by Ma multiplied by F. Okay, so in this session we have discussed about the heat unit. So heat unit is defined as the energy deposited at the target, or we can calculate through the heat unit kVp multiplied by Ma multiplied by exposure time. Okay, so through this session we will discuss about the we can understand the heat unit, or we can calculate the heat unit, the value of energy deposited or heat unit as a 3-phase or 6-phase circuit. Okay, thank you. The session is over. Namaste. Uh, in today's session, we will discuss about the cathode assembly. Cathode assembly in like that is in that is important component in the BScRT II. That is a session of General Radiation Physics second for BScRT citizen students. Cathode assembly. So let me discuss about the cathode assembly. Rotating anode axial tube. Rotating anode axial tube consists of a cathode and anode, which are kept in a glass bulb or glass envelope. Okay, so the rotating anode axial tube having two different charge, different potential electrodes. It's called cathode and anode, or that is kept in a glass bulb or envelope. The cathode is a tungsten filament which is offset from the long axis of the axial tube is to face the target near the periphery of the anode disc. To face the target near the periphery of the anode disc. Face the target. Usually rotating anode tubes are fitted with two filaments. One is larger than the other. Placed side by side in the cathode assembly. One filament is designed to focus the electrons on a larger area of anode. Okay, so one filament is designed to focus the electron in a large area of the anode, which requires heavy tube loading. So it requires heavy tube loading. The other filament is used to focus the electrons on a smaller area of target. This type is used when high resolution is required. It is for resolution. The first one is four line focus principle. Second one is the for resolution, for getting high resolution. This type is used when high resolution is required. Both filaments should focus the electron on the same part of the anode. So the focal spot is at the same point for both the modes of operation. Both the modes of operation. Some tubes provide two target angles or two filaments, so that each filament will have a separate focal spot. Smaller angle is used when the smaller focal spot. Okay, so then simply cathode is a negative charge electrode or negative potential at a negative electrode that is in negative potential. It has a filament that is in the form of wire or spiral. Okay, in rotating or stationary anode axial tube. The filament is made up of tungsten material. It works on the thermionic emission principle. When high voltage is applied by the source, electricity source, high voltage is applied on the filament emits electrons that having a high kinetic energy, and after that the electron strikes to the target, and the flow of electrons from the cathode to anode is controlled by focusing cup. Focusing cup focuses the electron from the cathode to anode. Okay, this is a negative potential electrode. Anode or target is a positive potential electrode. Okay, so cathode assembly having the filament, it has a focusing cup that is both the filament and focusing cup is at same potential in some cases, same potential in most cases. Okay, So thank you. The session is over. I think it will help to understand. I will. I think you will get a good knowledge after watching the video. Okay. Thank you. Thank you. The session is over. I think you are satisfied with this session. If you have any query, then put it into the comment box. I will resolve it later. Thank you. This session is over. The session is powered by digital version 2.0 JV'N University.